Okay, we've got one more example to look at. Here we go. We are looking at the reaction time while in a simulator. This, the simulation is of normal driving versus driving under the influence of alcohol, or DUI for short. Special goggles simulate the effect. We've got a sample of 9 teenagers. They're going to get matched with themselves. Some of them will experience using the simulator with unimpaired vision first and then using the goggles, while others will use the goggles first and then use the simulator with unimpaired vision. Why is that a good idea? Because we need 2 treatments to make this matched pairs. We need dependence, and this would control for any learning that may occur using the simulator. Use a 95% confidence interval to test if there's a difference in braking time. Okay, let's see. We've got a data table here. Okay, let's bring that up. And do not seem to specify which order to subtract in. I am going to go with impaired minus normal. I've shown in some other videos how we could use the TI-84. Here I'm going to open it up in Excel instead. Okay, so impaired minus normal is going to equal impaired minus normal. The reason I'm doing this is because I expect that the reaction time will be longer for those experiencing during those times when they experience the impaired driving, i.e. using the special goggles. Okay, so let's see here. Again, I'm not seeing a specification of which order. We need, from the differences, the mean of the differences on Excel. They do not have the word mean, they just have average. And we need the sample standard deviation, which you should see stdev.p versus a stve.s. That's for sample. I need to tell it which column. It's column D, starting with row 2 through column D, row 10. And furthermore, I do not see the table link in here, even though I do not see a question ID number with a -T here. There's no link to the table of critical T values. So 95%. First of all, since confidence intervals are two-sided as a percent, here's alpha over 2. And then dividing that by 100, we've got 0.025. So I use T inverse T. We want an area of 0.025. There were 9 teenagers in the sample, so 8 degrees of freedom. All right, so getting my lower bound, it's going to be the x bar minus that t value. I'm going to take the absolute value of that because in the table we would only see positive values. So minus 2.30600. And what else? 4133 times the sample standard deviation of the differences divided by the square roots of the sample size. And then for the upper bound, if I can copy this. Switch it to addition. So they want it rounded to the nearest thousandth. That is 3 places. We have 0.690 and 1.316. Based on that, in a hypothesis test that is two-sided, this would be with a null hypothesis of no difference, 0 difference. 0 is not within that confidence interval. It is below the lower bound. And so that would seem to suggest that we would reject H naught, finding sufficient evidence for an alternate hypothesis that there is a difference in the population for the mean difference about breaking time, impaired vision minus normal vision. Hope that helps. Take care. Stay safe and healthy.